Welcome back to the Scotti-BYTE channel, and this is Scott. Today I wanted to talk about KVM Virtual Machines 101. I normally advocate the use of container technologies like LXC, LXD, or Docker, which share the host OS kernel and are initiated from an image. Virtual machines also use images to emulate a disk drive, but the operating system is installed just like on a physical machine. Virtual machines have their own dedicated kernel, and virtual machines on x86-64 platforms started in about 2007, but early machine partitioning and virtualization began around 1965 with the IBM 370. Today, the core of virtualization is the hypervisor, which is the governing software layer that allows managing multiple VMs on a single computer. Common hypervisors are Microsoft Hyper-V, VMware, Oracle VirtualBox, Citrix Xen Server, Linux KVM, and many others. Hypervisors come in either what is called a Type 1 or a Type 2. A Type 1 hypervisor runs on a bare metal machine, whereas a Type 2 hypervisor runs on top of an operating system like an application. Type 1 hypervisors are dedicated to hardware that have hardware virtualization built into the CPU. Type 2 hypervisors often provide a software abstraction layer that can even allow virtualization on systems without hardware virtualization support. Hardware virtualization is an option that must be turned on in the BIOS of the motherboard in order to use it. Kernel Virtual Machine, or KVM for short, is considered a Type 1 hypervisor, but it somewhat blurs the lines because KVM is an integral module of the Linux operating system kernel. So Proxmox loads as a dedicated OS, which is based on a customized Debian kernel, and for that reason, many people would consider it to be a Type 1 hypervisor. Proxmox uses KVM and LXC to manage its virtualization. Proxmox is considered a Type 1 hypervisor because of that dedicated OS, as I mentioned. Vert-Manager is a desktop application in Linux that provides a user interface for managing KVM virtual machines through the libvirt toolkit. Vert-Manager, like Proxmox, manages KVM virtual machines. Vert-Manager can also manage Xen and LXC containers, although I haven't used it for that purpose. And Vert-Manager has supporting command line tools and a GUI interface for installing, viewing, cloning, and modifying virtual machines. So I've discussed nesting Docker containers inside of LXD many times on the channel before, and the Linux Virtual Machine Hypervisor, kernel-based virtual machine, can be configured to support nesting as well. In my previous video, Secure Shell from Windows, I showed how Windows Subsystem for Linux, WSL2, could be installed on Windows to provide a virtual Linux shell. In that video, I was actually running on an Ubuntu machine using a Windows 11 virtual machine, which was running inside of KVM. WSL2 was installed inside that Windows 11 VM because KVM supports nested virtualization. So in order to install KVM, you want to make sure that your computer supports virtualization. And this egrep command will determine that. If that command returns a positive number, virtualization is supported on your CPU cores, and it will tell you how many cores. If the number comes back as 0, make sure that your system supports virtualization and also that virtualization is turned on in the motherboard BIOS. And then you want to install KVM on Ubuntu. And in our demonstration, we're going to show how that is done. And these are the components you would be installing. And then we want to enable and start virtualization by enabling the libvirt-d daemon and starting the libvirt-d daemon. And then we want to add our account to two of the virtualization groups, one being the KVM group and the other being the libvirt group, so that we can manage virtual machines without having to provide the sudo command. And then, in order to enable KVM nested virtualization, we first have to check to see if nesting is enabled. We do that with the following cat command. And if that command returns a Y, then nesting is already enabled on your machine. To enable nesting on an Intel system, you're going to use this modprobe command and followed by this other modprobe command that can turn nesting on. And if you have an AMD system, just replace the keywords Intel with AMD. To enable nesting permanently, you want to go ahead and edit the kvm.conf file, and that file may likely be empty, or if it's not, go ahead and add the line that sets nested equal to 1, and you can change this value to be AMD if you have an AMD processor. So then we want to create a KVM virtual machine. We're going to launch the GUI program Vert-Manager to run the Virtual Machine Manager GUI front end. This is where you can add, modify, or delete KVM virtual machines. Now your virtual machines will support nested virtualization, meaning that your VMs can run LXD or even other VMs inside of them. Let's go see how to create a KVM virtual machine. So here we are at my Ubuntu desktop, and the first thing that I want to do is determine whether or not my CPU supports virtualization. And so I'm going to do the egrep command that we showed in the slides, and it returns a 12. If this had returned a 0, then we would have to go into our motherboard BIOS settings and make certain that virtualization is supported and turned on. Since I know virtualization is turned on, the next step is to install the components required to run QEMU. I provide my sudo password. Now that the required components are installed, the next step that I'm going to do is I'm going to enable the libvirt-d service so that it runs on reboot. And then I'm going to start the libvirt service now. Next, we add my username to the KVM group. And then we add my username to the libvirt group. Finally, I want to check to see if nesting is enabled with this cat command. And I get back a Y, which indicates that nesting is enabled. Now that KVM is properly installed and we know the system supports virtualization and also nesting, the next thing to do is to run Vert-Manager. So if I type Vert, bring up Vert-Manager, it runs, but it's going to require that you reboot the system before you actually use it. So we're going to come up over here, click on power down, restart, and we'll reboot the system. Now that the system is rebooted, we log back in and we execute Vert-Manager. And for convenience, I'm going to right click and add Vert-Manager to my favorites. So here's Vert-Manager, In order to create a new VM, first of all, you have to have an ISO for a VM that you want to go ahead and create from. So if I go into my files, my Nautilus file manager, and I look at my downloads, you can see that I have both the live server version of Ubuntu 22.04 and the desktop version of Ubuntu 22.04. So for this demonstration, we're going to go ahead and create an Ubuntu 22.04 desktop virtual machine in KVM. In order to do that, we click on the Create a Virtual Machine option here. And the first thing we get up here is the virtual machine wizard, which is 5 steps. We say we want to create it from local installation media. That was the ISOs that we just saw. I click forward and I click browse. Now you can notice that there's no real place here that indicates where those folders are. So we can come down here and click plus, and we can browse over to downloads and do an open. And then we can create a pool that just says something like distros maybe. And that's just where to look for the installation media. So now I can come in here from now on and just click on distros, and there's my 2 distros. And we said we're going to pick Ubuntu 22.04 desktop, so we choose that volume. And then we go forward. And then it says the emulator may not have search permissions for the path. Do you want to correct this now? Sure, go ahead and do that. And then what size do you want the VM to be? Okay, 4096 megabytes, in other words 4 gigabytes, and 2 CPUs is fine. It says there's up to 6 available. That's okay. I click forward, and then it says what size do you want to make the disk? 25 gigabytes is fine. This is just a demo. I click forward, and then it says what do you want to make this machine? I'll just call this Ubuntu-VM. And then I click finish. So it goes off and it creates that. I say yes, allow creating shortcuts. And now we have the login here, or the boot up process for if we had booted an ISO on a physical machine. I say try or install Ubuntu. I hit enter. Next, I click Install Ubuntu because that's what I want to do. English is fine. I click Continue. I'm going to click Continue and accept the defaults here. And I'm going to say erase the disk and install Ubuntu because it's installing it on that 25 gigabyte virtual disk we asked for. It says if you continue, these are the partitions that are going to be built. I say it's fine. Continue. I'm in the Chicago time zone. Continue. What's my name? Scott. What's my computer's name? I'm just going to say Ubuntu. Well, let's see. It has to be in lowercase. Ubuntu-test. Says that already exists on the network. Okay, fine. Let's just say Ubuntu-VM. And then I choose a password. And require my password to log in. And I do continue. Now that installation is complete, we have to click the Restart Now to reboot the virtual machine. We can now log in with our username. And we have the initial setup. I'll skip that and accept the defaults. And here we are at the Ubuntu desktop. Let's go ahead and bring up command prompt. And let's do a sudo apt update. and a sudo apt upgrade. And now that all the updates have completed, it asks us to reboot the virtual machine, so we'll click the Restart Now. After typing in my password and logging in, we have the desktop. And let's go ahead and run the terminal again. Since I use the terminal frequently, I'm going to right click and say Add to Favorites. And then I'm going to do a lexc or a sudo lexc list. And look, lexc is not installed. So I'm going to do a sudo snap install lexd, which will give us that lexc command line. It downloads this snap from Canonical, and now we're installing lexd containers. And of course, I have quite a few videos, probably over 30 on the channel, that talk about all the details for that. Now, if we try a lexc list, we get back the command and it appears to be working, but we have to initialize lexd first. So we're going to do a couple of things as we learned on the channel before. One thing we're going to do is a sudo usermod -a capital G lexd and add it to my user account Scott. And then we're going to do a new group on lexd, and we do a groups, and we can see that I'm now in the lexd group. So I won't need the sudo command to create containers. But I'll have to do a sudo lexd init to set the product up. No, I do not want clustering. Yes, I want to configure a new storage pool. The default is fine, and it will default to ZFS. That is also fine. Create a new storage pool. Yes. Would you like to use an existing empty block device? And that's fine to say that no. And then what size do you want for your loop device? It's going to say 5 gigs. I'll let that default. That's fine. Would you like to create a MOS server or connect to a MOS server? The answer is no. Do you want to create a new local area network bridge? The answer is yes. It'll create one called LexDBR0. I say select an IPv4 address for the bridge automatically. And then for IPv6, I'm going to say none because I don't want an IPv6 address on my bridge. And would you like LexD server to be available over the network? For right now, the answer is no. And would you like cached images to be updated automatically? The answer is yes. Would you like to print out the YAML file? No, that's fine. Now that LexD is initialized, I'm going to clear the screen on the terminal and do a lexc list, which I can now do without the sudo command. And you see we have no containers right now. And I'm going to create a very simple LexD container with the LexD launch, Ubuntu, and this time 20.04. I'm going to call the container myLexD. The default profile is required, and I'm going to say auto start equals true, which means that when the system reboots, it automatically starts the container. And now remember that case does count, so the word Ubuntu had to be lowercase, and I do the command again. It says it's now creating a container called myLexD. It's retrieving the image for Ubuntu 20.04 from the LexD repository, and it is now building the root file system, and that will be done shortly. Now that my container is created, I can do a lexc list, and I can see that it has an address. In this case, it has an address on an internal NAT that it's created. And if you want to know how to present that out onto your main LAN, you can watch some of my other videos that describe this. But we can connect to the container with a lexc exec my lexd and bash, and it will give us a bash shell into that container. And I can do an apt update on this container. And there you go. So we have a lexd container running inside of my KVM virtual machine. And if I exit out of it and do a lexc list, this is the one container that I created with Ubuntu 2004, but it's running inside of a virtual machine created by KVM that is running 22.04. And actually, I've been keeping a secret during this entire video because guess what? This whole desktop that I've been operating in here is itself actually a virtual machine. So the big picture you now see is my main computer. Inside of it is a virtual machine that I've conducted this entire video inside of. And inside of that, I created another virtual machine. And inside of that, I created a lexd container. So you can see just how powerful virtualization nesting can be. So in summary, KVM is a powerful virtualization hypervisor for Linux. If you use Virtualbox, consider trying Vert-Manager to manage KVM VMs instead. We looked at how to determine if your system supports hardware virtualization. And we learned how to install KVM and configure your system to support nested virtualization. Finally, we created an Ubuntu 2204 desktop VM in KVM. Anyway, that's it for today. Please subscribe and like to the channel, and don't forget to hit that notification bell. See you next time.